Question 19, part A is typical trigonometric ratio questions, and then in part A is just talking about 2D, so it's much easier to handle compared with 3D diagram. And then AC is the angle bisector, so we know that AC, this line, cut this angle to two equal parts. So we better write down the symbol to let us know that they have the same angle. After that, we have AB equal to 75, BD equal to 60. And also angle ABD is equal to 105 degrees. And then we are going to consider which triangle we are going to compare. In order to find out AD, obviously we are going to find a triangle, either the smaller one, including AD, or the bigger one, including AD. In this situation, of course, we prefer the bigger one because we have the total length of BD, while we don't have the path length of DC here. So therefore, you should draw exactly the same diagram with BDA not affected by AC. 105 degrees, 75, and also 60. Since this is not a right angle triangle, so we can't use the basic trigonometric ratio. We have to use the sine law or cosine law. About sine law and cosine law for any triangle, you have to think how many angles and also how many sine are involved. For sine formula, there are two. You are describing the relation between two sides and also two angles. For cosine formula, we are talking about the relation between three sides and also one angle. So don't forget to write down our target AD also. Our target is here. So including three sides, one angle, we are going to choose cosine formula. We can list out the relation by using cosine formula. Beware that the only angle we have is 105 degrees. And the corresponding side should place in the opposite side of the equation. So AD must be alone in left hand side. So therefore we have AD square should equal to another two sides 60 square plus 75 square minus 2 times of 60 times 75 times cosine that angle 105 degrees. We have this relation is quite easy to handle because AD is one side already. We just need to use calculator to get this value. Then we square root. We get the value of AD square, and therefore we take square root for both sides. So AD is equal to 107.491262 ... or AD is equal to negative value, but we reject it. And then later on, we have AD, we better write down 107 point something. We are going to find CD now. Again, including CD triangle, we are talking about the smaller triangle here. So we have to try our very best to gather all information which is related to this triangle. And at the same time, you have to realize that what kind of information we have is for the bigger triangle here. Basically, we have all the information. We can get any parts if we want. And because of this blue triangle, of course, we prefer to have any angle. If we can have this angle, then it's easier for us to solve. Therefore, the first step is by using the big triangle, I try to find out this angle first. Afterward, I'm going to divide by 2, therefore I can get these two values. In case that I have the values of these two angles, and then in case to try to find CD, this triangle we have one side, one angle is far more than enough. So therefore we don't consider CD here. But if you look at another triangle, if we have X, we have 105 degrees, we have 75, so it's possible for us to find CB. And therefore we just use 60 to subtract this section, we get our target CD here. After we set up our strategy, we are going to perform that. Our first target is find out angle BAD. Afterward, divide by 2, and then we apply to triangle ABC here to find out BC, and finally we get CD. This is our strategy. In this triangle, basically compared with sine formula and cosine formula, I prefer sine formula. It's a lot easier to handle. So I use sine formula. We have one set and then another set of data. So I can write down sine angle BAD, our target, divided by 60 should equal to sine 105 degree divided by 107.491262. And make sure you don't mix up the position, must be the opposite sides to the opposite angle. So afterward, we have sine angle BAD, multiply both sides by 60. So-called move the item to another side. Then we have 60 sine 105 degree divided by 107.491262 dot dot. And then you just perform the other side. Just simply use calculator, you get 32.62689296 degree. Afterward, we are going to work on this smaller triangle to focus on BC. So again, in your draft, just draw that triangle. Make sure you draw properly. And then B, C, and A here, 75 degree. This is 105 degree. And this angle is 32 point something divided by 2. So write down our finding. Angle BAC. This angle is equal to, just now that angle divided by 2, 16.313448 dot dot degree. Again, whenever you need to find the target, don't forget to write down your target. Your target is BC now at this moment. So now, including our target, we have one side, two sides, one angle, two angles. So we are going to try to use sine formula. One more problem is BC opposite is 16 point something, that's fine. But however, 75, we don't have the opposite angle, so we better use the angle sum of triangle to find out this angle first. Angle BCA is equal to 180 degrees, subtract another 2. After you get the angle, then we are going to perform the sine formula. This time maybe I put the line above the fraction line, so we have BC to our target, to this angle. BC to sine 16 point something should equal to 75 to the angle just now. 75 over sine 58 point something. Just simply change the subject. BC is 75 times sine 16 something divided by sine 58 something. So therefore we get BC, and then we just use 60 subtract this section, so we have CD length. Then we have the answer 35.34 something. That's the answer of part A. And then later on in question B, they say that just now the previous paper, we are going to throw it along AC. So you throw it here, and then you move this plane. You move A, C, D, this triangle. To ensure that the plane ABC and also DCA perpendicular. One thing very important to remind you is that they say the plane perpendicular to another plane doesn't mean the angle DCB are perpendicular. This angle is not perpendicular. Beware that it doesn't mean that angle DCB is right angle. It doesn't make sense if you really fold the paper. ABC is still remain on the horizontal ground, so you may consider it's your desk. And then we make sure this part of the paper are vertical. So they're asking for from D to the table, what is the corresponding distance? We are asking about this. And beware that if we find that from point B perpendicular to line AC from the graph is like this and here, and if I consider this is D prime, then you'll find that on the graph D prime is somewhere here while N is here. They do not converge at a single point. What you see here is not a normal paper, but this is a paper that we can fold. So in this question, they're talking about this triangle, and then we have to fold this part to make it become perpendicular to the plane. So you find that we just fold it until it is perpendicular to the horizontal ground, which means that that plane is vertical. And then in part B1, what is asking is talking about from this vertex, project vertically downward. What is the distance here? It is our concern. So to get the distance, you'll find that you just need to draw a right angle perpendicular with the horizontal line AC and also DD prime. Then we just simply use a simple trigonometric ratio with a length hypotenuse and also the opposite side here. So we just use sine ratio, we will get the answer. So if we consider the vertical plane D and D prime, where C is somewhere here, and then we have the sine 107.49 something, and also the angle 16.3 point something. Then we can just simply use a right angle triangle. With our target DD prime, opposite side and hypotenuse, we are going to use the sine ratio. We have this equation, then we just simply solve it by moving the denominator to another side, both sides times 107. Therefore, we get the total distance, the perpendicular distance is 30.19 something. Then it's come to the most difficult part of this question. They say that angle BCD is that greater than 105 degree. Basically, they just ask us to find out the angle BCD here. So you are going to consider this triangle in order to get the angle involved. And then you have to construct a line connecting B and D in a 3D diagram. Beware that in part A, we already have DC. We have BC here. So I have to draw this triangle. This triangle may be like this with DC and B here. And then angle DCB is our target. We have DC is 35.34 something. We have BC is 24.4587 something. In order to get this angle, we may get either one of this angle, but the difficulties are the same as this one, so it's not good choice. Or we can get the length of BD. So the BD is talking about the length here is still possible for us to find that out. And don't forget what is the hints given in part B1. B1 asks for the perpendicular distance. So we may consider BD, the perpendicular projection is somewhere here. If I can get this distance, then I can get BD by Pythagoras theorem. Because the projection of DB is on the horizontal ground, so I may use this graph to demonstrate. D prime to B, we are talking about this line. So it's possible that we use the same method in part B1. We get the vertical distance from B to N. We get the horizontal difference between D prime and N. Then we use Pythagoras theorem to find out this length, and therefore we get DB. Once we get DB, we can go back to this triangle and we use Cosine Formula to solve it. That means we fold it to right angle and then D project to D prime. On the horizontal ground, we focus on this right angle triangle. I get BN and also the horizontal differences to get this projection. So this projection, then we can use the perpendicular distance together with the projection to get the direct distance from point D to B in straight line. So let's start. First, we get BN first. Opposite hypotenuse, so BN to 75 should equal to sine 60.3 something degree, and BN is equal to 75 times this side ratio. Then another stage is the horizontal difference. D prime A is equal to opposite hypotenuse, so we are talking about the hypotenuse. Time cosine 16 point something angle again. Get the total length from D prime to A, then we get the length from N to A. Therefore, D prime N is the difference of them. So therefore, we can get the projection of BD. That means on the ground D prime to B. So we use the vertical distance square plus horizontal distance square and then square root the whole thing. Then we get this distance is 37 point something. So therefore, just now dB direct distance is the projection square, and then plus the projection square, and then square root, we get the dB distance by Pythagoras theorem again. So we did quite a lot to find out what is BD. Finally, we have the final key components in this triangle, 48 point something. Now is the final step. We use the cosine formula again. db square and then should equal to dc square plus bc square minus 2dc bc and then cosine that angle. So cosine that angle should equal to dc square plus bc square and then minus db square over 2 dc and bc. So we just change the subject, then we shift cosine, then we ask cosine, we can get the angle. We just plug in all the values that we have, and then we get the angle is equal to 105.67066935 dot square. And then compare with our target, is that greater than 105 degrees? Yes, it's greater than 105 degrees, so stay clearly about that. And then we should agree the statement. Then we finish the question. One of the special things of this question is we are going to apply the Pythagoras theorem in the 3D mode. We just use x difference, y difference to get the projection square, and then add the perpendicular distance square. We get the 3D distance. So I will agree that this question is quite difficult.